everyone. Welcome to my talk, Architecting for Failures in Microservices. My name is Bhakti Mehta, and before we get started, let me just ask you a question. How many of you deploy code to production? Please, can I have a show of hands? Perfect. Please, can you keep your hands up if you've never had any issues in production? Okay, then you all are in the right room, and this is the right talk for you. So the motivation for this talk is distributed systems fail in the most spectacular ways. There are times when it's a component which you would have never imagined for, which could become the root cause for one of the biggest incidents you would have. So with this talk, I would like to give you all some examples of real-life outage situations I have been in and how we went about proactively mitigating some of these issues which come up with incidents. A little bit about my background. I am in the platform team of Atlassian. I have a few folks from Atlassian in the audience right here cheering for us. So we support all the various Atlassian products. We provide services which would be used by the different products. So you can imagine at the scale of Atlassian, and if we are the platform layer for all the products, it is extremely crucial for us to be available, to be reliable, to take care of our SLAs, to take care of our throughputs, our latencies. So there is a lot which we have to worry about rather than just delivering a service. And we shall go over these. I will give you examples of what we do, how we are doing things in Atlassian, and we could follow up later with questions. If you have any questions, we could take it at the end of the talk. In the past, I was the platform lead at Blue Jeans Network. It is not in the garment business, and I don't know how many of you have used Blue Jeans Network. It is video conferencing in the cloud. So I was one of the first few employees at Blue Jeans, and we scaled to millions of users and dealing with billions of minutes. So you can see that there would be issues which come up at scale, and there would be outages which would happen. And I will talk about some of these as we go through the presentation. Before that, I have worked at Sun Microsystems for 10 years, and after the acquisition of Oracle for 3 years. One of the open source projects which I have worked on is the GlassFish. I'm not sure if you are familiar with GlassFish Application Server. It was a Java E7-based application server. It's in maintenance mode now. I have authored 2 books. This is my most recent book. This is on RESTful Java patterns and best practices. Some of the topics which we might cover later on in the talk would be based on this book. Before that, I have another book, which is on developing RESTful services with JAX-RS, WebSockets, and JSON. Honestly, I think I have a short-term memory loss because I forgot how hard it was writing the first book, and I still went ahead and wrote the second one. So, a little bit about Atlassian. You could see the various products, and I'm sure most of you are familiar with at least one, if not more, of the Atlassian suite of products. So like you most familiar would be like the Jira, the issue management software. There is Confluence for knowledge base. Bitbucket, I'm sure you've used this for your code and pull requests. There is Bamboo for the CI. HipChat is another product which we use for team collaboration. The newest additions would be the status page team and Trello, currently, which has joined the Atlassian family. So why this talk, and what are we covering in this talk? It is important. You could always learn from your failures, but it is more easier to learn from the failures of others. So in this talk, I will talk about how we go about microservices, what is the path to microservices, and then how would we go to build resilient systems. So most companies would start off with a monolith app. You know, it's got some UI, some control, the backend, and then there's the whole layer which they would bundle it, deploy it. And that would be the evolution of most initial products for a system. But then as time evolves, you realize that, okay, microservices is a new hot buzzword, but there are a lot of advantages with microservices. There is simplicity. A component would just do the part which is assigned to do. Say there could be a user service, there could be a billing service. You don't need to couple it together in a monolith app, like a monolith app. You could just separate it into various services. There is isolation of problems. Each service, say if one service goes down, it doesn't impact the whole application. At least that's what your goal should be, that even if there are transient problems in intermediate services, it should not impact your whole application. If this was a monolith application, the problems could not be isolated. Similarly, scale up and scale down. It is very easy when these are decoupled microservices. You can scale one based on how many instances you want. The other service may not need so many instances. Deployments become easier. Each team can take care of the deployments and manage it rather than going through the whole process of being bundled in a big monolith application. There is also advantage with polyglottism and heterogeneity. Each team can choose the language, the builds, the libraries, the frameworks of their choice, and they are not bound by whatever the monolith component dictates. So, all this sounds fantastic, right? In reality, so with microservices, this is what happens. When there are outages, it seems more like a group debugging a murder mystery. The sense we had, if it was a monolith application, there was just inter-process dependencies. Now we have changed it with network latencies. Now there is a user service component, there is a billing service component, there could be a category service. Now all of these have to work together, and any of them can fail at any point. And that is where it becomes extremely important to handle for failures. So now we move on to what is a resilient system. A resilient system is a system which could keep working even though there are these small roadblocks on the way. There could be transient impulses, there could be some stresses to the system, but it should just keep working. You have to accept, when you're building microservices, you have to accept that failures are going to happen, and you have to design for crumple zones. Just like a car manufacturer is not going to say, mine is the best car in the world, and not design and do the crash testing. Similarly, you have to expect the worst. You have to expect the unexpected and design for failures. Now, resilient system in terms of how a customer should perceive you. So I gave an analogy of a duck. So be the duck. So your customers should think that everything is behaving perfectly, and that's the way you want to portray, even though underlying there are going to be issues. But you want to make sure that you build a system which at least your customers perceive you to be stable and available, because that's where that builds your confidence for your customers. Internally, this is what you need to do. You need to heal quickly before your customers notice. There are error budgets for outages. You need to make sure you don't cross. You have SLAs which your customers are expecting from you, and you need to make sure that your system is available. And that is where you have to design for all of these failures. So a resilient system is one where the customers could perceive that everything is behaving normally, even though it might not. And on the other hand, on your side, you should try to heal as fast as possible. Now, let's talk about what would be the failures when you're building resilient systems. There are challenges at scale. I was at a meetup with Randy Shoup from Google, and he said, think of your software as artifacts you're going to throw away in 2 years, because there is always going to be challenges at scale. And what works now may not work in the next few years, because you have to anticipate that there is going to be growth, and you may have to re-architect your solutions. There are always integration point failures. There are network errors. There are semantic errors. We all make that. I will give you an example of an outage where a slow response brought down a whole system. There are hangs, And there are so many times where all of us have run into GC issues. Your APIs can take, the throughput can take a nosedive because it's doing a garbage collection. So these are the kinds of failures you have to anticipate and figure out what would be the best ways you would handle them. There was from Amazon, the first 2 lines. This is the new way of life. You build your services, you run them. I've added 2 more to it. This is how we do it at Atlassian. We own it, and we plan for it. So we are the dev team, we are the ops team, we are the QA team. So we not only build it, we not only run it, we are responsible, we get paged in production, so we make sure that our service is strong enough, because when you get paged at 3 in the night, that is not when you want to be sitting and debugging these issues. So this is the new way of life where you build it, you run it, you own it. We also plan the capacity for it. Right? You need to estimate what are the sizes, what are the instances. Say we are building, how many shards you need, you have to reprovision them. So we make sure of all of this. So that is where it becomes extremely important for us to figure out what are the things which would go wrong. This is one of my favorite quotes. Long gone are the days where people could say, oh, my feature is dev complete. No. Whenever somebody says the feature is dev complete, it is definitely not ready for production. There is a lot which goes to make a feature ready for production. There is a lot of operational expenses which you have to account for. So never consider that your feature is just dev complete and you are done. So now let me share a story about one of the outages where I was involved in. So this was one around sometime last year. I get a message on HipChat in the morning around 8:30 from a colleague. Hey there, are you there? And I'm like, okay, and he's definitely not calling me to ask about my commute on 101, because most of you who are local know how pleasant that can be in the morning at 8:30. So I'm like, okay, we are reaching an office, and we had started seeing a surge of 500 responses. So our error rates had gone up. And so the next thing what we do is like, okay, let's figure out what's going on. And there were multiple things which had happened overnight. There was a new code which was deployed. There was some nodes which were taken out by the ops team because it was of some issues. So, and it was the peak of the hour traffic. So we saw that there were a lot of errors, and that was causing the customers to have pain points to integrate with our APIs and get into the meetings and all. So the first thing you do is, as we talked, be the duck, roll back the release, got the nodes up, so the system went back to its stable state. Now it's the painful process of identifying what went wrong and what could we have done better. These are some of the things which went wrong in that outage. So when you are in the war room, believe me, it's not a good feeling. I mean, you are sitting and cranking what are the various possibilities that go wrong. And when there are so many things going wrong at the same time, you're really in a bad shape, because you have to come back to your normalcy, and you don't know when the next peak load hits, and you might go into an outage again. So we had bad nodes in our load balancer group. So by the time they were investing, so we were serving at fewer nodes than our usual planned, and we were handling the peak load. There was a new code which was deployed. Now there was one of the APIs was doing a very complex calculation on the back end. This was an API which would figure out, okay, which features, whether you as a user, would you have this feature or no? It figures out how to roll out features to users, enterprises, and it does a lot of complex calculation in the back. Now this API was gradually increasing in latency. So over time, it's like the global warming. Over time, it had become slower and slower. Now there were a lot of clients, mobile clients, web clients, who are depending on this API. And as everybody has their timeout set, if this API starts taking longer and longer, they will time out. And eventually, the clients will time out, and then you start seeing all these connection failures. On the other side, this new deployment had brought in an abuse from the client side. These APIs could be called where you could get all the features in one call. They would call multiple times for all of these, for every feature. There were cases where even if they have to display a button, whether it's orange or purple, the UI team always keeps on figuring out and trying these A/B tests. They started calling this API. Now, eventually, when the choice is made, they should ideally be removing these calls. But all this debris had accumulated over time. So it was being abused on the client side. So there are so many random network calls made which were really not needed. This is a problem which most of us face. You can test things in staging, but there is no data like prod data. So how much ever you try, there are sometimes some of these failures will never happen in a staging environment. Another issue we had is, say these features were there. There should be a way to trigger a lenient fallback. If I'm calling an API call and it's taking way longer than it's supposed to, maybe it should just return back a Boolean value, like a true or false, and continue rather than timing out. So we learned this over time, and we saw how many things went wrong to create that perfect storm and that outage. And we had alerts. But I think there should have been more alerts. There should have been more metrics on the latencies and how things were getting bad with time. This is a lesson which we have learned, that errors can be frequent, but the latencies are consequential. So there is a saying that if you want to know the value of a millisecond, you should ask an Olympic person who's gotten a silver. If you want to know the value of a second, you can ask a developer who's gone through an outage because of that 1 second. Our APIs were giving out a latency of 1 second, and that caused this huge outage. So don't underestimate your latencies, and ensure that you have some checks and balances in place. These were some of our action plans following that outage. We decided to have circuit breakers. We shall cover that in the next few slides. We decided to have fallbacks where it would be lenient values, which you could, if this API is not returning, what could be a fallback? We could do predictive caching. Say you are asking me for A, B, and C. I can anticipate that the next few features you would ask would be maybe D, E, and F, and I could just cache all of this proactively and provide it to the client. So the client doesn't have to keep asking me. I would just provide it predictively. We also asked the clients to reduce the surface area, and whatever features were already done, already rolled out, maybe that code should be removed. So there is some cleanup which needs to be done. Load tests. Load tests are extremely crucial, and we made sure that you try to get the same data as prod and more on your staging environments. Failure injection testing. There was a talk before where even Katie had emphasized on failure injection testing. You have to test for failures. Bring down nodes. Bring down your, all your dependencies. Bring down a component. Make sure you ensure that there are where your APIs take longer than expected. See how your systems function in those cases. And finally, work on alerts. There is a lot of emphasis on good alerting, and that will help you minimize this. So I have another caption, which is the more you sweat on the field, the less you bleed in war. The more rigorous testing you do in these environments, the less you'll have issues in your production. There is no way that you're never going to have issues in production, but you can mitigate these risks by doing a lot more in your staging and dev environments. So with this, I will go into 3 stages of resiliency planning. The first stage is what you would do when developing code. What are the patterns you would use? The second stage is what would you have to deal with if you are, before you deploy to production. And this is a checklist, and I would go in details in the next few slides. And the third stage is what would you do when you're watching out for failures after your deployment. After a big deployment, what is it you would look for? We also, at Atlassian, run crisis drills. So we plan for a day where, okay, we might take down some systems in an availability zone, and we see how the other downstream services are reacting to it. So we do plan for crisis drills, and this is definitely something which you should take into account, that run your crisis drills, because a real calamity is not a time for training. So ensure that you do failure ingestion testing. So what are cascading failures? Cascading failures are failures which are caused by chain reactions. Say, in my previous example, there was one node which was not doing well, there was a high load, and then there was APIs which were returning slowly, and eventually that adds up, those pile on, and finally your whole system can degrade. I'm sure most of you must be familiar with hystrix and circuit breakers. Basically, it works the same way like a circuit. Your current passes through it. At some point, the circuit trips, and it doesn't allow any more current to pass through. So the way hystrix works is, if some command has failed in the last 10 seconds, it is highly unlikely that it will pass now. So it basically opens up the circuit. It won't allow the command to be executed. And then periodically, it will sample to see, maybe this node was just coming up. So initially, first, you might have failures. But then if there is a success rate, it will allow more traffic to it. So I highly encourage you to use hystrix. Hystrix has very good metrics which you could monitor. There is a fallback option. So if you can always specify return from cache or return some stale data in your fallback option. Timeouts. All APIs should always have a timeout associated with it. We typically, for GET requests, would have like a 5-second timeout. And timeouts usually go with retries. So if you would call an API and you could wait for a while and then it times out, you can do another retry. Retries help in cases of transient errors. But retries should always go with a policy of, say, exponential backoff, where you don't want to, say a node is coming up, you don't want everybody to be flooding it with requests. So you would always have a policy of, say, exponentially trying after a fixed delay. So add some jitter in your retries. You should also specify what is your max number of retries. There are libraries which will help you do the retries. Failsafe is a good library. So you should just use these third-party libraries which would take care of the retry logic for you. Bulkhead. So just as there is a ship, and the ship has these various sections. So you can see each section is separated from the other. How does this help is, if there is a flooding in one section, it tries to avoid the water from spilling over to the next section. This is another pattern which we can apply in a microservices-based architecture. The way we do it is, if we have a microservice which is using a resource, say a database, we try not to share it between multiple services. Say you have a user service and you have a billing service. Try not to share the same database, because then you are introducing a single point of failure. If this database goes down, you are impacting two services. Versus if you have these isolated databases, it is going to just impact that one service. So that is a similar analogy to this bulkheads, where you have this section, and if that is having some trouble, the problem doesn't creep through the next few sections. Rate limiting. This is another aspect which you should be aware of. There will always be malicious clients, intentionally or unintentionally, who will be flooding you with requests. Your server can only handle a fraction of the requests. So at some point, you have to, if you're seeing too many requests from a certain IP, from a certain client, you have to tell them to slow down. This is extremely simple. Again, there are rate limiting libraries. This is as good as just adding a filter, and you can identify your clients by their access tokens, by their IPs, and you can figure out how many requests they are making. If the requests are exceeding a threshold, then you should send them an error, say retry after X number of seconds. So this helps you to evenly span out and avoid malicious clients from taking down your service. Caching. Most of the latency problems can be solved by having a good caching story in place. So I have some analogies, like if you have some data which you can fetch from your first level cache, it is like getting a beer which is right there in your hand. If you are getting it from a second level cache, it is still not bad. You might just have to walk till the fridge and get the beer. But if you have to fetch something from the database, it is like driving cross-country to get a glass of beer. So cache often, cache well. I have another story I would like to share. This is about the cache invalidation. Whenever you use caching, it is extremely important to figure out what is your time these cache entries would stay in the cache. So we had this API which would take in, so most of you are aware, you will get like an alphabetic code sometimes which you have to enter to verify. And that API would take in, give in 5 letters without the vowels. So we thought there was ample space for, and these were stored in the cache. So every time a code is generated for you, it should be a new code which should not be there in the cache. We noticed this didn't take us an outage. This was found out in a load test where we noticed that at some point with load and over a period of time, since each of these entries were valid for 24 hours, we actually ran out of letters and validation codes which we would give the people. So the immediate fix was you could increase the number of letters, but then that involves changing all the clients. We could reduce the time to live in the cache. So since the 24 hours was too long, we made it to 12 hours. So if I have given you a validation code which you need to enter and verify yourself, maybe after 12 hours, I think that was realistic where the code is not valid anymore. So this was a case where initially the plan was, okay, we have a lot of, the load is never going to be this much. Let's keep the time to live as 24 hours in the cache. And we saw with a load that didn't work for us. So make sure you invalidate your caches well and you have proper TTLs set in for your cache entries. Logging. So whenever there is a production issue, logging and your metrics, they are going to be your best friends because there is no way else you're going to identify what went wrong in production. So there are best practices for logging. Logging would be have a consistent pattern which you can identify across services. We use MDCs a lot, which identifies what is an event type, what is the source. We put all of that information in our MDCs. We use Splunk for logging, so then we can do a stats, a count by groups. So logging is extremely crucial, and make sure you have a consistent pattern. You have libraries which you use across your services to ensure you get the proper logs in production. Another thing is most of these, you obfuscate the sensitive data. You don't want your client-related data to be showed in your logging, especially when you're doing SOC 2 compliance and all, because there would be PIIs in the data, so never log payloads by default. Trace your requests across services. So there is a call which is going from user service to billing service. There are libraries like Zipkin, which can allow you to trace your calls. It can help you figure out how much time each call took. So you can see which are the bottlenecks in your system. So ensure that you have request tracing across all your services. One more point I had over here was to identify the initiator as part of your logs. There were many times when an API is called, but when it is logged, if you don't know whether it was the web client calling or whether it was from the mobile, if you could add in extra headers and that is passed on to the logs MDC, that helps a lot in debugging where you know that this sample of failures were occurring only on the mobile clients. So identify your initiator as part of this, your logging. So we covered a lot of resiliency planning practices when you write code. We talked about caching, logging, we talked about timeouts, retries, circuit breakers. Now we move on to the next stage, which would be before you do a deploy. So it is extremely important before you do a deploy to do a load testing, a longevity testing, and also to plan your capacity accordingly. The way we do it is we have a staging environment, and during running these loads and longevity tests, we ensure that our staging environment is similar to the prod with the same number of instances, and we'll try to pass in the load which we anticipate, which would be over the next 6 months, and see how our system behaves in terms of load. We also have a microservice which takes in Gatling simulations and all the data from other services, and that runs it. So it's like a load test as a service. So it would take in the microservice endpoint it needs to hit, the environment, what is the load you want to give, what is the duration, and then it would plot in graphs. So that is how we do load testing in our various environments. Capacity planning is another area which you need to invest in. You need to anticipate growth. You need to see if the instances you had provisioned initially are sufficient enough to handle this volume of requests. If not, maybe you have to scale out, you have to upgrade your instances, change your descriptors, provision your resources accordingly. So capacity planning is also something which is very important before you deploy your code to production. Now, we move into the third stage of resiliency planning. This is when you've deployed your code to production. At that point, you need to worry about health checks, monitoring your system, and phased rollout of features. So what is health check? The way health checks would work is, say you've deployed your system to these environments. Each service could be checked for some basic attributes like memory, CPU, threads, error rates. You monitor your system for this. If any of these checks are going above a threshold, you send an alert. So this is known as shallow health checks, where you're monitoring your system and seeing if it is healthy. If not, then you remove this service from the load balancer group. There could be deeper health checks, where you could look for your downstream dependencies. Say I have a service which needs a zip. It's a prerequisite that I have to fetch a zip from another service. If that zip is not available in my microservice, it doesn't make sense for me to operate. So we do these kinds of deep checks where we check if this is not there, I declare myself unhealthy, so I could be removed from the AWS cluster, and a new instance could be spawned up which would make these requests. So these are the kinds of deep health checks also we do. So there are shallow health checks, and then there are deep health checks. This ensures that the health of your services is acceptable when it is deployed. The next thing which you would watch for post a deploy would be metrics and monitoring. So metrics, again I said whenever there is an incident, the logging and metrics are going to be your best friends. You can always go back in time and see how were the patterns at that point. So we have metrics for everything. We identify metrics for response times, for throughput. We see how long it takes to execute queries, and we'll have metrics for that. And we see if there is something which is taking longer than expected, maybe send an alert, so at least you can identify and see what's going wrong. There are metrics for GC rate. Basically, there are metrics for any unusual activity. There are alerts which are created whenever a threshold is exceeded. Now, whenever an alert is created and a person is paged, we try to have these runbooks. These are runbooks for actions to be taken. So now say you get an alert, say your node is run out of memory. What are the next steps which the person could take? So what we do is we try to do these operational runbooks, which anybody new person in the team would also be, if this is a failure, these are the steps he needs to take. This helps them identify the system and help to the system to recover quickly. So we invest some time in building good runbooks. So this is just a light note. So this is what happens when you are paged at 3 and you are debugging somebody's code. And you definitely don't want somebody to look into your code and be figuring out what to do at that point when there is a production incident. So I thought I'll just put in some light humor when we are talking about so many serious things. So this is what a monitoring server does. It looks at the environment, and it checks if everything is healthy. If not, if there are some alerts, if there are some values which have gone over the threshold, it sends alerts. And the alerts could be in the form of emails. We use PagerDuty, so we can get paged, and you can set your preferences, so you can get paged, and then you respond to the alert. I have another story to share, and this was an example of where we got saved by metrics and alerts. I was on call one of the days, and we started seeing these alerts coming where the database, there was a max DB connection alert. So we have a max number of DB connections, and we were going way over that. And then that caused the CPU to spike up. So the first response would be, okay, you go and look at whatever the slow running queries. We found out some of the culprits, and then you identify that, okay, these queries were taking on an average 718 milliseconds, and then the 95 percentile was taking 2 seconds. So you know that there is some problem in this query. The next step was to identify what caused this. And this was a code push, which was done for a bug fix earlier. And all it did was it added pagination, and there was an order by clause. But the order by clause did not take a function-based index. And that caused a whole table scan with millions of rows. And that caused all of this to spike up. And then since it was being loaded in memory on startup, we started seeing the CPU utilization spiking up. So these are small cases where we were saved by the alerts. This was still, we have alerts in our staging and our prod environment. So this was something in the staging environments. So we didn't have to take it to prod and see an outage. We identified it way earlier, and we could rectify the situation. We put in another patch, and we deployed the fix for it. So this is another case where metrics and alerts can be extremely useful. Rolling out of new features. So whenever you roll out new features, the way typically it is done is you want to launch them dark and do a phased rollout. You should roll out maybe to 5% of your customers, see the feedback, then move on. So always ensure that there is a phased rollout so you can see if there are issues, you can catch them earlier rather than just doing a 100% rollout. So we typically do a phased rollouts of all our features. And again, whenever you roll out, have metrics, have alerts. So you know if something is wrong, you could just turn off the feature and work on the fix. So this was another incident I'm sure you must be aware. AWS had an S3 outage. This was around 2 weeks ago. Did any one of you get impacted by the S3 outage? Okay, I see a few hands, so you know what I'm talking. We did not survive this. I cannot say that we are the proud owners of this t-shirt. So we also saw, and I'll give you some context on what happened that day. So it was an AWS S3 authorized team member who was supposed to remove a few billing servers, and he had a run book, he had a script, but there were some parameters which were entered wrong. So whenever we ran that, it took out a lot of nodes on the S3 instances. And it also took down another system, which was a metadata system, which held information about all the other S3 nodes. There was a placement system which would help you create, update more S3 nodes. So all of them went down with the running of one script. The impact was heavy on most of the services. Not only, okay, we got impacted, but the services we used to monitor, like PagerDuty, New Relic, metrics, none of those, they themselves were affected. So that is where you see like a badly run command, and you could see the repercussions. So some of our services could easily recover and went to another provider, CDN. Some of our services which were not in US East were fine. But we had a lot of key takeaways from this outage. This just shows the fragility of the system. It was a simple mistake on the S3, on the AWS end, but the repercussions were wide across a lot of teams. And we were one of them. So yeah, we learned, and we do test for availability zone failures. But testing for multi-region and failures and the easy failover, it is hard. Also, in these times when the AWS S3 is not working as well in US East, if you try to spawn off resources in other regions, it doesn't really work well because AWS will start limiting you. So because they don't want a thundering herd. So at these points, if you try to create new resources, it is not going to work. So either you have to plan for and pre-provision resources in all regions, or you have to handle. But this was like an example of like a small error on the Amazon side and all the cascading failures which happened to downstream services. So I have this cheat sheet. I've studied in New York, and the way we used to do it before our exams, our professor used to give us one sheet of paper and say, cram as much as you can in this sheet of paper, and this is what you can bring for your exams. So old habits die hard, and I thought, if there is something which you could take away from this talk, I would think it would be this cheat sheet. We've covered a lot of these topics, and I think this is something which would help you architect and build resilient systems in the future. I ran out of space to complete the alphabet, so maybe take that as a homework assignment, but I hope this is useful to you. I'll leave it on for some time if you need to. So with that, the key takeaway is, yes, systems will fail, expect systems to fail, plan for failures. It is not a question of if, but is the question of when. So make sure you take control of your systems before they overpower you with incidents and outages. Automate as much as you can, plan for automation, alerts, metrics, all of these are extremely crucial to keep your systems up and running. And finally, keep calm and cloud on. So that's all I have for today. If you have any questions, you can ask me now. And we also have a booth in the exhibit hall, so we would be waiting there afterwards. So if you want to continue, we can have conversations over there too. So any questions for me? Okay. Yeah. Any questions? Okay. Thank you for attending this talk, and thank you, Devox, for giving me this chance.